Hey guys, welcome back to another video. I've been especially excited for this one as today we're going to be talking about the Devonian period. Now, the Devonian period was an extremely important period regarding the evolution of land-dwelling vertebrates. Spanning between around 419 million years and 358 million years, this period is sometimes called the Age of Fishes because of the diverse abundance of fish in the Devonian oceans at the time. Forests began to emerge, creating swamp-like environments, and the coiled shell-bearing marine organisms known as ammonites first appeared early in the Devonian. Late in the period, the first four-legged amphibians appeared, indicating the colonisation of land by vertebrates. A highly varied invertebrate fauna that originated from the preceding Silurian period continued in the Devonian, and most ecological niches of shallow and deep marine water were exploited. The remarkable proliferation of primitive fishes, which has given the period the name the Age of Fishes, occurred both in fresh and marine waters. And as always, we are going to speak about some of these creatures that inhabited the Devonian period, so enjoy! With squid-like tentacles extending from their distinctive multi-chambered shells, the extinct marine predators known as ammonites were once among the most successful and diverse animals on Earth. Scientists have identified more than 10,000 species from fossils found nearly everywhere on the planet where oceans once existed, from the Great Plains of North America to the foothills of the Himalayas and the glaciers of the Antarctic. Ammonite is actually the colloquial term for ammonoids, a large and diverse group of creatures that arose during the Devonian period, which began around 416 million years ago. Ammonoids are related to other cephalopods such as squid, octopus and cuttlefish, and they were actually early relatives of the modern nautilus. Meanwhile, true ammonites are a suborder of ammonoids that didn't appear until around 200 million years ago in the Jurassic period. Based on fossil records, ammonites came in a wide range of sizes and shapes, from smaller than an inch to as large as 9 feet wide. Some ammonites had long straight shells while others had helix-shaped shells. Most species, however, had coiled shells lined with progressively larger chambers separated by thin walls called septa. The many chambers of their shells likely helped these cephalopods glide through the planet's warm shallow seas. A thin tube-like structure called a siphuncle pumped air through the interior chambers of the shell, which scientists believe helped provide buoyancy and move ammonites through the water. It's unclear whether ammonites were actually very efficient swimmers, however. And due to the great number of ammonite fossils found, we can conclude that this creature was very successful during the Devonian period and further on during the timeline. So this is Stethecanthus. Now, as a prehistoric shark, Stethecanthus immediately stands out from its modern day brethren. Unlike the triangular dorsal fin that people associate with sharks today, the dorsal fin on Stethecanthus was shaped more like an anvil. In addition to the unusual shape, small spikes covered the growth as well as appearing on the top of the head. These spikes were larger versions of the placoid shells that cover the entire bodies of sharks and work by reducing drag and allowing sharks to swim more efficiently. It is still unknown what benefit these large spikes provided, but with its distinctive dorsal fin, Stethecanthus would have had no problem recognising others of its own species. Further, it seems that only the males had this brush of spikes. Two long cartilaginous tendrils also trailed from the back of the pectoral fins, but their purpose isn't exactly known. It is thought that Stethecanthus dwelled in coastal waters, feeding upon fish and cephalopods much like modern sharks do today. Large quantities of Stethecanthus teeth concentrated in some locations has led to the speculation that Stethecanthus may have migrated to breeding grounds during the course of its life. However, due to the size of Stethecanthus, most scientists predict that they were more bottom feeders rather than active predators hunting fish all the time. Now, this is an exciting one. This is Dunkleosteus. Now, in modern popular culture, Dunkleosteus is by far the best known and most often represented of the early placoderm carnivores. Aside from armour, the bony plates of Dunkleosteus could have served two further purposes. As a predatory placoderm, Dunkleosteus likely attacked other related placoderms that had the same kind of bony plates for protection. In the absence of harder organic material, Dunkleosteus would at least need the same material to break through the armour. Shape the material to a sharp bladed edge and you have a chance of cutting through it. This is what Dunkleosteus did with its jaws. The second reason is that the jaws needed enough driving power to cut and break apart armoured prey. The only way that this could happen is if Dunkleosteus had an incredibly powerful jaw muscles. However, these muscles would in turn require strong supports and attachments, otherwise the jaws would not be brought to bear with their full force. This is likely why Dunkleosteus and other related placoderms like Eastmanosteus retained armoured heads. Although Dunkleosteus had a powerful bite, it was not the strongest among fish. That title goes to the gigantic shark Megalodon that lived several hundred million years later. Still, with a bite force estimated at almost 2 metric tons, Dunkleosteus could still use its sharp jaws to shear through any prey item it chose. What prey items were on the menu seem to have been dependent on the age of the Dunkleosteus in question. Juvenile Dunkleosteus had stiff jaws best suited for soft-bodied prey items. As the Dunkleosteus grew older, the jaws would become more flexible, perhaps to better protect them from injury and breakage when dealing with larger, more powerful and more heavy armoured prey items. Finally, because Dunkleosteus was at the top of its food chain, the only other thing that it would have to worry about was being attacked by another Dunkleosteus. This actually does seem to have happened, with some Dunkleosteus plates actually showing damage that seems to have been inflicted by the jaws of another Dunkleosteus. Aside from territorial combat, this may indicate active cannibalism in Dunkleosteus. So the next creature we are discussing is the behemoth known as Titanichthys. Titanichthys is a genus of giant aberrant marine placoderm from shallow seas. While Titanichthys appears to have been as large as the fearsome Dunkleosteus, it does not seem to have had the same apex predator lifestyle. Dunkleosteus had jaws that were incredibly sharp for biting through the armour of other bony placoderms, whereas the jaws of Titanichthys were actually very blunt in comparison. A possible scenario is that Titanichthys used its huge mouth to swallow up large numbers of small shoaling fish that were together, or perhaps even to filter for krill-like invertebrates. If true, then this would make Titanichthys one of the earliest known filter-feeding fish. Now this is Acanthostega. Although it's possible that Acanthostega could walk on land, the morphological features of the body suggest a primarily aquatic lifestyle. Neither the spine or ribs were adapted to support its weight while on land. The legs, though large, lacked the joints and degrees of motion required for efficient terrestrial locomotion. The underside of the creature had heavy scales, a feature that may have protected it from regular contact with the ground, especially if it hunted in the shallows. If it were able to spend short periods out of the water, the scales might have also helped protect the body as it was dragged over the land, perhaps if the creature was moving from one body of water to another. These and other features do point to a predator that was suited to life in the Devonian swamps. As matter is decomposed by bacteria in an aerobic process, oxygen is used up, reducing the oxygen content in the water. Acanthostega had lungs as well as internal gills, and this lung backup would have allowed it to exploit the oxygen in the air as well, something that predatory fish would not have been able to do. The legs, while crude compared to the land animals to come, would have enabled it to scramble over and around submerged obstacles and aquatic plants. They would also have allowed it to free itself if it beached itself in shallow water while pursuing prey. Perhaps the most important feature is the teeth and jaw. Fish typically use the suction method of feeding. This is where the predator opens its mouth so fast and wide that it creates a vacuum inside its mouth that sucks water and prey inside. In comparison, Acanthostega jaw and teeth featured 2 fangs. This was more suited for actually biting onto prey. This terrestrial method of feeding suggests that it focused its hunting around the water's edge, as opposed to exclusively hunting submerged. Many creatures during the Devonian period, like Acanthostega, identified a transition between mainly aquatic vertebrates and vertebrates that decided to make the first step onto land and take advantage of an ecological niche that hadn't been exploited by vertebrates before. That's been it from me, guys. Hope you enjoyed another video on this Paleogenius channel, and have a great day. Also be sure to leave a like, subscribe, and let me know in the comments what you want to see next on this channel.